Hello, in this lesson, we're going to talk about solving absolute value function, equation, and so on and so forth. Okay, first we like to recap what we did with absolute value function. We did it in the first week. Okay, it's been a while ago, but this is a very, very important function. At the time, we plotted the points. Okay, we plotted the points and one by one, right? We plotted those points and we talk about these two pieces of narrative. We talk about these two pieces of narrative, which is about the absolute value of a non-negative number is the same as the number, and the absolute value of a negative number is its opposite. So this function is so important, okay? I don't want you guys just to forget about it, right? In fact, we do this piece now, and we're going to do this piece later once more. And so this function and its equations being covered multiple times throughout the semester, and I just promise you, you will get to use it in calculus 1, 2, even 3. Okay, very, very useful, important function. And we know that there are two properties that the absolute value function have. And these are either product or quotient. And these are not right. They are mistakes. Okay, you cannot use these. These are common mistakes. And the if statement, right? Of course, we're going to talk about absolute. This lesson is about solving absolute value function. And what does it mean, right? And if we know the input, for example, right, for this function, if we know the input, if input is 2, f of 2, the absolute value 2 is 2. So it's a vertical cut, right? So we draw this vertical line because x equals to 2, and we draw the line, we draw the vertical line, cross the curve, and that's where we found the output. So input, output. Solving absolute value equation, however, is to give the output and to identify the input. For example, x1, the first example. Solve for x, the absolute value of x equals to 2. What does that mean? What does that mean? It means that given the output equals to 2, and we're looking for all the possible input or inputs. Okay, we may have input that costs, we may have the input such that the output equals to 2, and we want to find all of them. Okay, and we're going to discuss all these different cases. We're going to discuss all these different cases, right? So here I want to give you some different perspective. Okay, the function perspective, right? If we know the output is 2, then we're going to draw horizontal line. And this horizontal line crosses the curve at 2 points. So these 2 points are telling us, what is these 2 points telling us? Okay, these 2 points are telling us, number one, there's a point here, right? The input is -2 and the output is 2. So I'm going to mark these 2 points for you. Okay, so input a -2, the output is 2. Okay, so here we have, say, I'm going to mark these 2 points. Okay, and this is going to be, so this point, okay, -2, 2. So I need to redo it. Okay, I'm not satisfied. Maybe 5.5, 1 point. Yes, this is better. So this point tells us when input is -2, the output is 2. So that input is going to be one of the inputs to be identified. So we found one, and we have another one. We have another one. And this other one, I'm going to mark it Okay, right here, 2.2. And this is going to be let's see if this will work. Okay. So the meaning of these points, not totally satisfied with it. So I'm going to do let's see if this works better. Oh, this is even more ugly. So let me just try it one more time. Okay, positive 2, 2, and we're gonna make it like that. Okay, yay. So these 2 points, right? When we draw this horizontal line, knowing the output is 2, we draw the horizontal line. It crosses the curve twice. Each point tells us the input, when input is -2, the output is 2. When input is 2, output is also 2. So the solution will be +2 or -2. Okay, so this is the function perspective. Knowing the output and the output, we draw the line we're drawing here. The line we're drawing here. Okay, I'm going to mark the line we're drawing here. The line we're drawing here is y equals to 2. Why we say y equals 2? Because typically we say x is the input, y is the output. Right? X input, y is output. In fact, actually, I did not introduce any y here. Okay, but this y is connecting what you have learned before, right? So y is really f of x. Y is really f of x. Okay, I'm gonna write that down for you. It's just in a little bit. Okay, so this is going to be, hopefully we're going to mark this properly. Okay, so you make these connections. Okay, so y equals to 2. This is too high. Okay, y equals to -2. I'm sorry, y equals to 2. And now, I just do that. Is that better? Yes, this is way better. Okay, you can see the process from the function perspective. When we draw that horizontal line, not only we can identify the points in this case, right? Sometimes it may be difficult to identify the points, but it does tell us how many solutions shall we expect. We should expect 2 solutions from what we saw on the picture. And this is the advantage of doing it from functions perspective, and you know what to do, and then the rest is just how to find it. Okay, so this is the first method. Method 2. Okay, method 1 is we do the function perspective, right? We do the function perspective. So I'm going to take this picture and I want to replace this picture because I think this picture is better. Okay, this picture is better. So with that said and done, let's look at the second method. Okay, the second method is something you're familiar with. Okay, from the definition, right? The definition says the absolute value is the distance between an unknown number to 0. We don't know the unknown number, so we know 0. So from 0, we start to measure 2 units. 2 units to the left, 2 units to the left, and 2 units to the right. So we ended up with 2 numbers. So the solution is going to be +2 or -2. How do you show your work? And that's all you need to show your work, really. Right, so that's the first question. A number line, right? You can show your number line. So you don't need to draw the graph. You can tell the solution from the number line. Okay, second example. The second example, I'm also going to show you this function perspective, right? Since we know the output is 0, so I'm drawing this horizontal line. See, in fact, I'm going to make that horizontal line to be to be solid. Okay, to be solid, not broken. Okay, not broken. So this horizontal line crosses the curve once, and that point 0, 0 tell us what? When input is 0, output is 0, and we have only one solution. And similarly, we can do this on number 9, right? The distance between 0 to 0 is 0, right? The meaning of absolute value. The next one, example number 3, okay? We know the output is a -3, so we draw the horizontal line, -3. No touch, no touch, no solution, no solution, okay? On the other hand, we do have very powerful tool for this, illustration, because the absolute value of any number is at least 0. That means there's no number will make the absolute value equals to -3. So this sentence turned out to be very, very powerful, very, very powerful. Okay, so let's summarize. We have these 3 cases. Right? On these 3 cases, right, we're solving for x. If absolute value of x equals to 2, then the absolute value, we have 2 solutions, right? Actually, I'm going to bring that picture, bring our other picture, the picture I modified. I think I like that picture better. Okay, this illustrates much better. Right there. Right? So there's touches twice, there are 2 solutions. Touches once, no solution, 1 solution. Touches at no time, no touch, no solution. No touch, no solution. And these concepts can be generalized, right? You can see I turn x into what? Into omega, y omega. Everything the same, right? Everything the same. Omega, the absolute value of omega equals to 2. So you can view this as some kind of model, okay, as a kind of model. But omega can be more complicated than just a single variable, okay? That's our intention here. For example, right? In the following examples, suppose our omega is 2x minus 1 equals to 2. In that case, our omega is 2x minus 1. So we just use this model, right? We know there are 2 solutions. We know there are 2 solutions. We just have to set 2x minus 2 equals to 2 or 2x minus 2 equals to -2 and solve these two equations, so we get 2 solutions. We still get 2 solutions. And so in this case, omega is 2, right? The second one, and which model does it fit, right? Example number 5, we treat this as omega. So if the absolute value of omega is 0, then omega must be 0. Right? So we're going to follow this model. And from absolute value 5x minus 3 equals 0, then 5x minus 3 must be 0. Therefore, x will be 3/5. Just one solution. Okay. Now let's look at number 6. The absolute value of omega is equals to -7. In that case, our third case, there's no solution. And therefore, this piece has no solution. Okay. So are there other situations of solving absolute value equation? Absolutely. But most of them we have categorized over here. Okay. So we have summarized in these cases. okay, right here, all right? So for solving absolute value equation, we have these three cases in general, okay? I think that's all for this lesson of solving absolute value equation. We have lessons to solve absolute value inequality, but that's going to be another lesson. So thank you for watching.